Alright guys, so today I'm going to be doing an example of the Durbin-Watson statistic problem. So I'm going to read the problem out loud just in case you guys can't read it. It says, in this semester the number of students who wanted to take Stat 2 was more than the considered capacity of the class. To avoid this issue in the future, Ms. Mackenzie Booth fits a regressional model to predict the demand for this class using the last 20 successive semesters' data. The Durbin-Watson statistic is 0.921. So the first thing that you're going to look at is this 20 right here. That's going to be equal to n. So you can go ahead and write n equals 20. And Durbin-Watson statistic, which is your d value, which is always given to you, is 0.921. So just to double check and make sure that everything is in order, you're going to look over here. The semester columns are the numbers that you're going to be concerned with. You're not really going to be using the data for the number of students each semester. You're kind of looking for a sample number, if you will. So the first question, A, says at alpha 0.01, what are the values of DL and DU? So this is when you're going to look at your D table, and you're going to look at your N value. Zoom in. It's your N value, which is 20 right here, and come straight across to alpha 0.01, and your K is equal to 1, so you're going to come down to 20, and so your DL is going to be 0.95, and your DU is going to be 1.15. So also, I forgot to mention that you know that your K value is equal to 1 because all of these semesters are independent from one another. Just wanted to point that out. So the next part of the problem asks if there's evidence of positive autocorrelation. And what you're going to do for that is look at your formula sheet that says if D is less than DL, yes, there is evidence of positive autocorrelation. And if D is greater than DU, then no, there's not evidence of positive autocorrelation. So you're going to look at your D value here, and here your D is 0.921, and you're going to see that yes, that is less than your DL value here. So yes, there is evidence of positive autocorrelation here. So the next part of the problem asks if there's evidence of negative autocorrelation. And again, you're going to look at your formula sheet that tells us if your D value is greater than 4 minus your DL value, then yes, there is evidence of negative autocorrelation. And if your D is less than 4 minus DL, then no, there's no evidence of that. So again, we're going to use our D value that we were given, 0.921 is less than 4 minus your DL value, which is 1.15. And so after subtracting that, you see that 0.921 is less than 4, is less than 2.85. And so because, like up here, it says if your D value is less than 4 minus your DL value, which in this case it is, then no, there is no evidence of negative autocorrelation.